All right, hello. Got your windy day calc video ready to go here. So I would grab a piece of paper, take notes like you normally would in class. It's been a while since you've seen some of this stuff, and there's a quiz coming up. So watch this video, and hopefully it'll remind you of everything we were talking about before break. All right, so before break, we were talking about distance, displacement, and arc length. And those are the first topics I'm going to review today. After that, we're going to start some log review back from Algebra 2 and Pre-Calc. That's kind of our last major topic before we start some AP review at the end of the year here. So here we go. So today is day 99. 100-day party coming tomorrow. And you can call this more distance and arc length. Actually, more distance and displacement. Those are kind of the topics that go together. And arc length. All right, so the quiz that you have this week is going to have both of these topics on it, in addition to some volume still. But we talked about both of these topics the days leading up to break, so that's what I wanted to start with. So here's the first question. Given v of t, so the velocity, is equal to 2t squared minus t minus 6 for t greater than or equal to 0. I want to find, without graphing calculator, both the displacement and total distance over the interval from 0 to 4. Okay, so before break, we talked about how to do this. Displacement, if I was going right for a while and then coming left for a while, displacement is just the end point minus the start point. So essentially, if I could find my position at the end minus my position at the start, I would have the displacement. Okay, well, since velocity is the derivative of position, that means displacement always equals the integral over your interval from 0 to 4 of velocity. And we talked about before break, integral of velocity is position. So this is essentially finding the position at 4 minus the position at 0, which is exactly what we want for displacement. Position at the end minus position at the start, how far you ended from where you began. So in this case, that's going to equal the integral from 0 to 4 of 2t squared minus t minus 6 dt. And that would just equal 2t cubed over 3 minus t squared over 2 minus 6t evaluated from 0 to 4. Now it does say without a calculator, without graphing calculator. So we need to plug these values in, and you need to do it without a calculator and show me enough work so that I can believe that you didn't just plug this in. So 2 times 4 cubed over 3 minus 4 squared over 2 minus 6 times 4. Plugging in 0 is just going to give us a total of 0, so minus 0. All right, so we start doing this. 4 cubed is 64 times 2 is 128, so 128 thirds. Minus 4 squared over 2, that would be 16 over 2, so minus 8, minus 24. So that's 128 thirds minus 32. And you have to think of this as over 3. So if 32 was over 3, I'd multiply the top by 3 also, which would be 96. So 128 minus 96, that is 32 thirds. Everyone's favorite answer. Okay, so we got a displacement of 32 thirds. Now total distance is a little bit trickier. Total distance, I have to figure out this distance here plus this distance there. And again, we talked about how to do this before break. That's dependent on the change in direction. So right here, we change direction. How do I know the direction changes? Well, if you're changing direction, that means temporarily your velocity equals 0. So I got to figure out where my velocity is 0, find the distance between here and here, and then this distance is going to be negative, so I'm going to have to take the negative integral when I go towards the left. So for total distance, our first step is going to be to set velocity. Let's change the color here. Set where velocity is equal to 0. So in this case, I have 2t squared minus t minus 6 equals 0. And if you factor that, that's going to be 2t and t. We need a 3 and a 2, so put 3 there, 2 there. And if I do minus there, that's minus 4t plus 3t. Okay, so velocity equals 0 when t is negative 3 halves and when t is 2. Now, negative 3 halves, don't have to worry about because we're only talking about positive time. Then we need to partition. So there's 0, there's 2, and my endpoint is 4. And we're partitioning velocity. Okay, so if I plug in 1, we'd have a positive times a negative. So it would be negative here. If I plug in a 3, positive, positive. So that means here I'm going to the left, here I'm going to the right. Okay, so then total distance, I want to get the distance. The left displacement is going to be negative. We only want to count it as a positive distance. So we're going to take the negative integral from 0 to 2 of velocity and add that. When I move to the right, displacement's positive, so I just take the positive integral from 2 to 4 of the velocity. Okay, so velocity is the same equation we had up here. So this is going to be the negative of 2t cubed over 3 minus t squared over 2 minus 6t evaluated from 0 to 2 plus 2t cubed over 3 minus t squared over 2 minus 6t evaluated from 2 to 4. All right, so slightly obnoxious because we don't have a calculator. When I plug in 2, this is going to be the negative of 2 times 2 cubed over 3 minus 2 squared over 2 minus 6 times 2. Plugging in 0 is just going to give that 0, so I don't have to worry about that. Plus, over here, now think about it, when I plug in 4, we already know that. From up here, when I plug in 4, we got 32 thirds. So I can just say 32 thirds minus, plugging in 2 is going to be the same as this. So minus whatever I get from this piece. I'll fill that in a second. Okay, so this is negative of 2 cubed is 8. 8 times 2 is 16, so that's 16 thirds. 2 squared is 4 divided by 2 is 2 minus 12. Fill that in a second. Okay, so this is 16 thirds minus 14, but 14 over 3 would be the same as 42 thirds. So this is negative 16 thirds minus 42 thirds, because that's the same as 14. Over here, we still have our 32 thirds minus whatever that comes out to be. Okay, so 16 thirds minus 42 thirds. 16 minus 42 is 26, negative 26. So this is a negative 26 thirds. And if you fill that in over here now, negative 26 thirds Just trying to save myself some time there. All right, so that's actually going to become a positive 26 thirds. Okay, good. Adding those two together, 26 plus 32 is 58 thirds. And this is really a positive 26 thirds. Adding those two together, we get 84 thirds, which actually does reduce to a total distance of 28. All right, so hopefully the concept isn't too difficult. The algebra is a little bit obnoxious. Remember, if you have a calculator, there's an easier way to get total distance. What can you do if you have a calculator and want to find total distance? Right, absolute value. So if I just did the integral from 0 to 4 of the absolute value of that velocity, 2t squared minus t minus 6 dt, we should get 28 also. So let's try that real quick. If I math 9 it, we have the absolute value of 2t squared minus t minus 6, comma x, comma 0, comma 4, and 28, 28, 28. There it is, 28. Okay, so if you have a calculator, which you will on the test this week, and I ask for total distance, just take the absolute value of velocity. You get the same thing. All right, any questions with distance or displacement? If there is, go rewatch this section of the video. Moving on to question 2 review. Arc length question. A little different than what we've done in the past though, and this is on the quiz. Find the equation of the curve y equals f of x that goes through the origin and whose length can be found by length equals the integral from 0 to 4 of the square root of 1 plus 1 over 4x dx. All right, so like I said, this is a twist on arc length, and there is a question identical to this on the quiz coming up later this week. So you definitely want to write this one down and follow along on how to do it. So arc length, again, it's been a while since we've done it, but arc length is the integral from a to b, so the length of the arc from a to b, of the square root of 1 plus dy over dx squared dx. And that's to find the arc length of y equals f of x. So that's the formula for arc length. You can definitely see, you can figure out what a and b are really easily, although it won't really matter to us. We've got the square root of 1 plus, so it all comes down to this. What is that thing equal to? Well, 1 over 4x has to be the same as dy over dx squared. So that helps us. We can say dy over dx squared has to equal 1 over 4x. Now, incidentally, do you remember the other qualification with this? This only works if something's true. If dy over dx is continuous over our interval. So this one's a little iffy actually, because at 0 this isn't continuous, but since that's an endpoint, we can get around it, and this still works. But really, maybe I should say 1 to 4 here, so there's no worry at all, because I'm not going to give you that little extra worry. 1 to 4, this derivative is continuous, so this should be fine. Okay. So if I want to figure out what y is, the original equation, the equation of the curve y equals f of x, I'm looking for y, we've got to get dy dx alone first. And how do I do that? Right, take the square root. So now I have dy over dx equals 1 over 2 radical x. So square root of 1 is 1, square root of 4 is 2, square root of x is radical x. That's why that looks like that. That's what dy dx is. If I want to get y, what do I have to do? Right, I have to take the antiderivative or take the integral. So really I'm taking the integral of 1 over 2 radical x dx, which is the same as I can pull a 1/2 out times the integral of 1 over radical x dx. And if you're going to do that, we would want to rewrite this as a power. So 1 over radical x is the same as x to the negative 1/2 dx, which would be 1/2 x to the positive 1/2 over 1/2, which is going to cancel that out right away. What I forget though, plus c. So right now I have y equals x to the 1/2, which is the same as radical x, plus c. Okay, now how do I figure out what c is? Well, if you go back, it's the equation that goes through the origin. So what's that tell us? That tells us that the point 0, 0 is on the graph. So that's what I can use to figure out what c is. Okay, so if I plug in 0 for y and 0 for x, oops, that should be on the graph, which just means that 0 equals c. So my final answer is y equals radical x. Okay, so remember how to do that. If I ask you for the original equation given an arc length formula, it's that piece that's the derivative squared. So you got to unsquare it, take the integral, use your plus c along with your initial condition to figure out what that original equation was. So it's kind of working backwards with arc length. Okay, any questions with that one? All right, so both this first question and this one, good questions to know for the quiz later this week. Tomorrow I'll be giving you a review sheet for that quiz. You can try questions like that on your own. All right, so now for the new stuff, which isn't actually new because it's review. The last type of function we have to talk about this year are logs and exponentials. So in order to do that, we got to remember some properties of logs. So here's log review day 1. All right, so the big thing, the reason why logs exists is because of their relation to exponential functions. So exponential function versus log function or logarithmic function. Logs are the inverses of exponentials. So if I have some base raised to some exponent equaling some number, there's an equivalent log expression, log base b of that number equals the exponent. So I don't usually think of it like this, but just for a quick review, we know 2 cubed equals 8. The base is 2, the exponent is 3, the number that's equal to is 8. Logs are just another way to express that. The base is 2, log base 2, of the number 8 is equal to the exponent of 3. So the thing to remember is that the answer to a log is an exponent. The way I prefer to think of logs is that logs undo exponentials and vice versa. So for example, if I have log base b of x equals y, if I wanted to get rid of that log, I could exponentiate both sides by b. And that means the base is b. What was written originally is now the exponent. Whenever the base is the same as the log base, they cancel, and I get x equals b raised to the y power. Other way works as well. If I started with b to the x equals y, if I wanted to get rid of that base of b, I could take the log base b of both sides. So log base b of b to the x equals log base b of y. Again, when the base of the log is the same as the base of the exponent, they cancel, and I have x equals log base b of y. So that's really how you want to really think of logs, as an operation that undoes exponentials. So generally, when we first start out with logs in Algebra 2, we ask you to do questions like this. Rewrite in log form. So if I had 4 to the third equals 64, if you're comfortable jumping right to the answer, that's totally fine. If you'd rather do the mathematical way of taking the log base 4 of both sides, so log base 4 of 4 to the third equals log base 4 of 64. Log base and the base 4 cancel, gives me 3 equals log base 4 of 64. Now it's in log form. And remember what that means. 4 raised to what exponent gives you 64? The answer is 3. So again, if you want to skip this middle step, I'm totally fine with it if you're comfortable. If logs aren't your thing, do that middle step. You'll get the right answer every time. Here's a couple more. 25 to the 1/2 equals 5. If I wanted to make that in log form, what's the base here? 25. So I take log base 25 of both sides. So log base 25 of 25 to the 1/2 equals log base 25 of 5. These cancel. My answer is 1/2 equals log base 25 of 5. And again, take a minute to just realize what that means and why it makes sense. 25 to what exponent equals 5? Well, the square root of 25 equals 5, which is why the exponent's 1/2. All right, let's do one more like this. Number 3. 9 to the 0 equals 1. If you're going to do the log way, what log are you going to take of both sides? Right, log base 9. Log base 9 of 9 to the 0 equals log base 9 of 1. These cancel. I'm left with 0 equals log base 9 of 1. 9 raised to what exponent gives you 1? Well, anytime you raise something to the 0 power, you get 1, which is why the answer is 0. Okay, so that's rewriting in log form. Now I want to go the other way. So for this next few examples, I'm going to say rewrite in exponential form. Number 1, log base 1/2 of 8 equals -3. Now, if I want to write in exponential form, I got to get rid of the log. So the base is 1/2. I exponentiate both sides by 1/2, and this side cancels because the bases are the same. I'm left with 8 equals 1/2 to the -3rd. And just like above, if you're comfortable with skipping right to that step without showing that, I'm fine with it. But if logs are a little tricky for you, this will always work. 1/2 to the -3rd power is 8, because 2 cubed is 8, and the negative would flip it. Number 2, log base 7 of 7 equals 1. What would I exponentiate by? 7. So exponentiate both sides by 7. They cancel. I have 7 equals 7 to the 1st. That's obviously a true statement. And last one like this. Log base 2 of 1/16 equals -4. To rewrite this in exponential form, I would exponentiate by 2. 1/16 equals 2 to the negative 4th power. True statement, because 2 to the 4th is 16, the negative flips it. All right, so hopefully that's a quick review that seems familiar. A couple other facts you should know. ln of x, what base is that? That's actually log base what? Right, e. So log base e to x. And the other one, what's log of x if there's no base written? It would be log base, good, 10 of x. Those both have special names. ln is called the natural log because it occurs in nature a lot, the way that growth happens. And log base 10 is the one that's used most commonly, so it's called the common log. All right, well, we're almost done already. I know, sorry. The last thing I want to do is evaluate some logs. So I'm going to flip to one new page. Here we go. All right, so evaluate each. What is log base 3 of 27? Now, some of these, if you're good with logs, you're just going to know the answer right away. So what's the answer? Remember, the answer to a log is an exponent. So what exponent goes on a base of 3 to get 27? 3 to what power equals 27? 3. So the answer is 3. Now, if you're not good with logs, again, you can make an equation out of it. You can say log base 3 of 27 equals x. That's what you're trying to find. Exponentiate by 3 to ditch that log. Then it's 27 equals 3 to the x. Then it's easier to see what the answer is. X equals 3. Okay, how about number 2? Log base 4 of 2. Think about it for a second. What do you think the answer is? 4 to what power gives you 2? Well, since the square root of 4 is 2, the answer is 1/2. Now here's how you get it the other way. Log base 4 of 2 equals x. And exponentiate by 4. 2 equals 4 to the x. Now you might not remember exactly how to solve these. We haven't done them too much, but you need common bases. And the common base between 2 and 4, what they can both be written as, is 2. 2 is 2 to the first. 4 is 2 squared, still to the x power. So once you have the bases the same, you can set the exponents equal. 1 equals 2 to the x is 2x. So 1 equals 2x because we multiply exponents when you have an exponent raised to another one. There's where the x equals 1/2 comes from. All right, a couple more. Number 3. What is log base 8 of 1? Think about it for a second. You got your answer. 8 raised to what power gives you 1? Well, regardless of what the base is here, if I've got a 1 here, my answer is always going to be 0, because any base to the 0 power equals 1. All right, number 4. This one's the trickiest, I think. Log base 8 of 16. Now, it would take me a while to really think about what exponent has to go on 8 to get 16. Because 8 to the first is 8. 8 squared is 64, so it's somewhere between 1 and 2. But it's kind of tricky to think about. There's going to be radicals involved, everything else. So why don't we set this one equal to x? Exponentiate by 8. You'll have 16 equals 8 to the x. Now what's the common base? What can both 16 and 8 be written as? Well, if they're both powers of 2, this is 2 to the 4th. This is 2 to the 3rd, still raised to the x. Once your bases are the same, set the exponents equal. So we have 4 equals 3 to the x is the same as 3x, so 4 equals 3x. So it's actually 4/3. I bet some of you probably could have done that in your head, which is really good if you can. If you recognized 8 is a perfect cube, that's why the third is there. So take 8 to the 1/3 power to get 2, raise it to the 4th, there's your 16. So that's why it's 4/3. All right, last one. It's actually pretty easy if you really understand it. What if I asked for ln of e to the 6th? What is that the same as? Well, what happens with ln and e? When ln and e are next to each other, this is the same as log base e. That's a base of e, so they just cancel. When you see ln and e next to each other, you're just left with the exponent, which should be 6. All right, so that's it. We'll do some more log review in class tomorrow, along with talking about the quiz a little bit more. But hopefully you watched this video, took good notes, because what we talked about is going to matter on this upcoming quiz this week. Check your email for any assignments that I'm assigning based off of these notes, and I will see you tomorrow.